There are many mysteries of the universe that we don't fully understand and can grasp. There are also ones that we will swear is true, and yet we can't actually prove them as of yet, either because we haven't found the proof yet, or we don't have the technology to go and get the proof. Such is the case with the dark matter and dark energy, two mysteries of space that many have hoped to prove by this point in time. But with a new piece of technology now in space, we might have a chance. Allow us to show you the James Webb Telescope terrifying discovery of dark matter. The origins of dark energy and dark matter. To know what dark energy and dark matter is on a basic level, we need to look at the very beginning of the universe itself. You see, scientists believe that the universe had stopped growing after the Big Bang, or at the very least had slowed down from the rapid expansion that created the universe. Which would make sense when you think about it, because after a while the expansion would have to stop, right? But then, in 1920, Edwin Hubble made a discovery that the universe was still growing, and it didn't show signs of stopping. This sent many scientists into a tizzy because it wasn't clear what would cause the universe to continue to expand. Could the energy from the Big Bang truly have been infinite, or was something else coming forth to cause the expansion? The answer that was found, in theory at least, was that of the concept of dark energy and dark matter. First up, dark energy. This principle posed by scientists is that it's a type of energy that is literally pulling at the universe, thus allowing it to expand. All matter in the universe have a type of gravity, and that holds the universe together. But this dark energy is pulling it apart in a way that counteracts the gravity of the universe without destroying it. Which is a good thing, because it'd be the opposite of pulling at something like Play-Doh until eventually it breaks. We currently don't have to worry about that. And then there's the notion of dark matter. This arrived in thought in the 1960s and 1970s by scientists stating that the universe is made up of more than we can just see, and it's through this invisible matter that the dark energy may truly come forth from. It's invisible, but it's there. Now, I'm sure your minds have been blown and confused multiple times during that explanation, but there is a small bright spot for those who are still confused. Mainly, both of these concepts are still just theoretical. Despite many sciences backing up that it could be out there, no one can prove that it is, or at least hasn't proven it yet. Dark matter in particular is nearly impossible to capture, especially with our perceptions of it right now. As for dark energy, it's hard to define it, let alone prove it. The Large Hadron Collider is said to be a stepping stone to getting dark matter, but it's unclear if it will truly produce what they need to prove the theory. Only time will tell on that front, and it's not as easy as it sounds to just make the collider work. Granted, this is all the most basic of ways to define things, but as you can tell, this is a major concept that could very well change how things are perceived in our universe. Dark matter goes beyond invisible. One of the biggest problems in proving the notion of dark matter is that it's something that is invisible, and thus hard to detect. But it's more than just being invisible to the naked eye. After all, our own science and life are full of things that can't be seen by the naked eye, and yet are visible with magnification or other spectrums. So, is that the case with dark matter? Are we just not looking hard enough? Well, no. That's part of the mystery that is dark matter, because it is invisible. But it also doesn't emit any radiation or signature that would show up on the electromagnetic spectrum or radar. Scientists have many tools to detect all kinds of radiation and have used them on satellites in space to see what they could find. And yet, despite these tools, we haven't been able to detect dark matter. That's not to say that we're giving up. Far from it. It just means that scientists have to refine their tools and abilities even more to try and find dark matter. Plus, it could be that dark matter emits an unknown kind of radiation or energy, not meaning dark energy that we don't know about. Anything is possible at this point, and that's why a lot of hopes are being put on the James Webb Telescope to help give us better clues to everything that goes on with dark matter/dark energy. Dark matter holds galaxies together. So, given all the theories and mysteries around dark matter, you might be wondering why we think it exists at all outside of the expansion of the universe. To that, many would answer that many scientists believe that dark matter is the reason that galaxies exist as we know them. How does that work when the Big Bang apparently created everything? Simple. While the Big Bang was the creation event, many scientists have noted that galaxies shouldn't stay together in their current forms, meaning they shouldn't rotate in place. Instead, they should just fly apart. but instead they stay close, most of the time anyway. There are exceptions to the rule, and become formed objects in space. The reason for this is that dark matter has gravity, and scientists feel that because there is so much dark matter in the universe, up to 85% depending on which scientist you talk to, that the gravity exerted allows them to stay as one. Again, not fully proven, but it's one of many physics and math models that seem to explain the presence of dark matter without fully proving it. But hopefully, with the James Webb Telescope, we can finally prove it. So, let's break down that telescope, shall we? Why the James Webb Telescope could potentially discover proof of dark matter/dark energy. The Webb represents the culmination of decades, if not centuries, of astronomy, says Sarah Seeger, a planetary scientist and astrophysicist at MIT. We've been waiting for this a very long time. Scientists started thinking about a follow-up even before the Hubble Space Telescope launched in 1990. After more than 3 decades in space, it's unclear how much longer this boundary-breaking satellite will be able to scan and photograph the universe. The Webb was originally supposed to launch in 2010 and cost around $1 billion. Its price tag ballooned to $10 billion, and it's way overdue. But the wait will be worth it, at least according to the scientists who expect new and revealing glimpses of our universe. We're going right up to the edge of the observable universe with Webb, says Caitlin Casey, an assistant professor of astronomy at the University of Texas at Austin. And yeah, we're excited to see what's there. The Webb improves on Hubble in 2 key ways. The first is just its size. Hubble was about the size of a school bus, whereas Webb is more like the size of a tennis court. This thing is enormous, Strawn says. Webb is by far the biggest telescope NASA's ever attempted to send into space. But it's not just the total size of the contraption that matters. When it comes to reflecting telescopes, the key component is the size of its curved mirror. You could sort of think of a telescope mirror like a light bucket, Strawn says. The more light you collect in this bucket, the fainter and further away things you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter. Webb's beautiful gold-hued mirrors combine for a diameter of 21.3 feet. Overall, that amounts to more than 6 times the light collecting area, and with that amount, we could finally get detections of dark matter/dark energy, potentially. The mystery solved? Nothing is ever solved until it's proven definitively. But what we have here is a situation in which things could get very good very quickly once things work out with the James Webb. The telescope is still in the very early stages of its life, and as such, it'll likely be a while before we get anything truly groundbreaking with it. But should it really go and make a discovery about dark matter/dark energy, we could have a way of redefining our universe forever. And that's pretty exciting. And you know that many people have been waiting a long time to see if they were right about this thing or not. So what do you think? What do you think of this look at the James Webb Telescope and whether it can well and truly figure out the mysteries of dark matter/dark energy? Do you think that with this advanced telescope we can finally answer the question once and for all? Or do you think that this is something that'll never be solved? Let us know in the comments below, and we'll see you next time on the channel.